Hey, how's it going, everyone? This is John here at The Drone Life, and welcome to this podcast episode. And today we're going to be talking about the 7 most common questions about drones and solar. So, some of the things we're going to be learning today include how drone inspections work from start to finish, how do drone inspections of PV systems save money, how long does these aerial inspections actually take, how accurate are drone inspections of solar farms, do drone inspections require plant downtime, can I use the drone data for warranty claims? And then, what is the best program, in-house or outsource? So we're going to be covering all this today in this podcast episode. But before we get started, I want to do a brief introduction. So, like I said, my name is John. I'm the owner of a drone company called The Drone Life from New Jersey. We primarily do a lot of inspections for the solar industry and travel around the country doing these infrared inspections of these large solar farms. And I'm joined here with my co-host, Robin Clark.
Hey everyone, I'm Robin. I work for Nexamp. We're a large solar company here in New England. Specifically, I'm the remote pilot manager at the company, so I'm in charge of running our SUAS program and being a manager, managing our equipment and our pilots, as well as contracting out any third-party work to inspect our sites. So John and I have a lot in common in terms of professionalism with drones and doing infrastructure inspections, and in particular photovoltaic inspections where using a thermographic or an infrared camera to do inspections of the panels of the modules and be able to kind of do like a health check on things and see where anomalies might be, what's broken and what's not broken, and how things are working efficiently.
Yeah, so getting into the first topic here, so how does the drone inspection process work when we're doing these larger PV systems? So, as I'm sure a lot of you know, traditionally we would do different inspection methods like IV curve tracing or handheld thermal imagers, and sometimes even just walking around doing visual inspections. And so, really, the first thing that happens is you get on your site with your aircraft. So there's a few different aircraft models that are really popular out there in the market. We have DJI is a big one. You have the Matrice line of drones. You have the new Mavic 2 Enterprise fleet of drones, which have thermal cameras on there, and as well as do you know any of like the other popular stuff?
Oh yeah, sure.
Robin?
There's, you mentioned DJI, so they're the biggest right now. They have the most market share. Parrot would be the next popular one, and also for commercial applications. Unique is another one. We actually have a Unique drone in our fleet. SenseFly is another one. I think I'm pretty sure SenseFly.
Yeah. They had the fixed wing. They do fixed wing.
Yeah, that's the fixed wing. Yeah. I'm sure there are others that are also available, but just don't have the same kind of notoriety as the ones we just previously mentioned. Those ones kind of have a little bit more of the market share. Skydio, that would be another one. I guess like maybe less so because I haven't really seen them focus on infrastructure. They're more focused on developing their collision avoidance algorithms and like how many more cameras can we fit into this thing. Is what I've seen. Kind of more like the cinematography aspect of flying versus doing inspections. Those are the ones I've seen that are pretty popular.
Yeah.
I mean, DJI is the one though that like you can just walk into a Best Buy and just be like, "Oh, well, I'll take that one," and as opposed to the others where like you probably will click and hit the order button and wait a couple weeks before they show up on your doorstep. So yeah, DJI just tends to be like the most accessible, the most popular, and at this point, like the best price that I've seen in terms of like packages, variety of different setups in terms of like camera options, collision avoidance sensors, and just also like receiving firmware updates pretty consistently. Just like usually their products always seem to still be in development, at least the ones that they're still actively supporting.
Yeah, basically, like we were just talking about, like the inspection process really revolves around the drone and like the different thermal camera, different equipment you have on. But what else kind of goes into the inspection? So you're gonna also have some kind of application to do, like it's called flight planning. So these inspections are actually pretty autonomous. So the drone is actually going to be flying like all the panels really by itself in most cases, and the pilot is really there to monitor and make sure everything's pretty much going smoothly. So there's different applications out there. Like you can have, if you have DJI, they have DJI Pilot. They have GS Pro, and then I'm sure there's some other ones that are really popular. I know Drone Deploy is working on some kind of solar inspection platform as well. And so, in these applications, really what you do at the at the solar farm is kind of map out where the drone will be flying, and then you put in all these different settings like the altitude. We actually have a whole video on our YouTube channel about exactly all the settings that we put into, like say it was DJI GS Pro application and how the whole that inspection process works. So you can go check that out if you want. But the next thing, what about the weather, Robin?
Oh, doing pre-flight planning and checking weather. Yeah, that plays a pretty big part. I mean, especially for solar inspection. So, obviously you don't want to be going out on a cloudy day and trying to capture good data.
Yeah.
Maybe contrary to what some people think. The solar panels do still work in the cloudy weather, but not as effective or efficiently. So to get the best readings and to get the best data, we tend to go out on sunny days, whereas little clouds are out in the sky as possible. So always checking the forecast and trying to look at that 3-day forecast, most accurate one, to predict what days are going to be best or most suitable for an aerial photovoltaic inspection. I don't know if you're familiar with it. Now, there's a device that reads the irradiance level in watts per meter squared. And we're always looking to make sure that irradiance is above 600 watts per meter squared. That tells us that we're going to be, that if anomalies are out of sight, that they will be present during an inspection. Typically, if the irradiance is under that, you might not be seeing the full picture, so to speak. So it might seem like everything is operating and functioning normally at 100%, when in fact there are issues that you're just not detecting because that irradiance isn't at the right level. Other weather-related things that we look out for is humidity, right? So if you have moisture in the air, water does a pretty good job of absorbing heat. And so if like the ambient temperature of the air, of the moisture in the air is higher, that can throw off the readings you get off the solar modules. So we tend to try and make sure we're flying with humidity percentages lower than 70% or somewhere thereabouts. We can find the exact number, but it's usually right around like that percentage is what we try to make sure and avoid, mitigate. That's not to say if like it's a really humid day, like well, we can't fly. Like we definitely can. It's just we have to also keep in mind that the data might, those temperature values might be shifted a little bit higher because of that. So it's something we have to be cognizant of when referring to the data from that inspection day when we're looking to make conclusions from a report.
Yeah, and sometimes with the clouds too, if it's not like a fully overcast day, I think they say like generally like if it's like 2/8 octas or like 2/8 of the sky is covered in clouds, if any more than that, like you don't want to be doing the inspection because like say if it's like a really partly cloudy day and there's just a bunch of clouds coming in and going and the sun's kind of peeking through all the time and you're doing the inspection, then certain parts when there was sun, you're going to get good data. Then other parts when the cloud covers it, if you might be missing a lot of the anomalies. So that's definitely something to keep in mind as well.
Yeah, absolutely. I tend to look at satellite imagery. So like there's the geo orbital something stationary satellite. It's like GOES, GOES. And that does a pretty good job of allowing us to see like satellite imagery of, the Northeast or whichever particular region that you're flying in, so that you can get an idea of what the cloud cover is like. Because right, if you have like thin, stratus, like wispy clouds at a high altitude, those are pretty, I guess, like have a lot of opacity where light's gonna get through them pretty easily and still make it to the ground. As opposed to like if you have big puffy cumulus clouds that are very dense, light doesn't
Mm-hmm.
penetrate those as well. So and you have like these really, they cast these big shadows, which is I think what you
Yeah.
were talking about on the ground, which will really throw off your inspection, and you want to try to avoid that during try to avoid flying when those are around, or at least a lot of them. Like if when I'm looking at the, I tend to refer to NOAA a lot for weather forecasting. So like they have a sky coverage, estimator evaluation metric,
Mm-hmm.
and if that's like above 60, or 70%, I tend to just write that day off and just go like, all right, it's probably not going to happen. It's not worth it. It's not worth driving a few hours out to this site just to have a lot of like cloudy weather to try and fly around that and try to like mitigate that is kind of difficult. It's better to just go out on a day where you're not going to have very many clouds, and you're going to
Mm-hmm.
be able to work in pretty sunny conditions.
Yeah, definitely. So weather is a really big factor. And so once we actually, it's a nice day, and once we arrive at the site, then we start setting up all of our drone equipment. So, a really important part, which actually comes from manned aviation, is having pre-flight checklists. So you probably have like this whole list of stuff that you're looking over. Take say like for example, you're inspecting the propellers on the drone and all its different components, making sure that there's no damage to anything, especially stuff like batteries. Because drones are primarily always being run off batteries and not like some kind of gasoline or anything. So
Yeah, typically not.
these,
Don't really hear drones with like
yeah.
a piston engine like revving in the sky. It's like, whoa, what is that? Flying weed whacker?
So yeah, but the batteries, always have to be charged up, and you have to, be sure to look at those and make sure there's like no swelling happening or anything, because especially at like when you're doing these like infrastructure inspections, you don't want to have some kind of battery malfunction and then the drone falls and like potentially can start a fire like within like all the field. So you definitely have to. That's definitely something to really keep watch out, and also a good point to put out too is, a lot of these sites are in the desert area, like say on the west coast, like in the Nevada area, and it would get super hot in the summertime, and so when you're doing the inspections, you can't really just leave all your batteries out like in the sunlight either, especially when they're fully charged, because yeah, the heat. If you just leave them out, while doing the inspection, and you just you have like a bunch of them to swap out for the whole day. That heat at the end of it can really actually cause them to fail, like instantly when you're out there flying. It just will happen without you even realizing it. So
Yeah, lithium polymer batteries definitely have a temperature window you want to keep them in, right? Like too hot, you're gonna have degraded performance. Too cold, same thing, right? Like if you've ever gone skiing and your cell phone's in like your outer pocket, you take it out, like it's pretty much dead, but it's also like
yeah,
frozen like a brick, and you're like, but I just charged this thing. It's like no different with lithium polymer batteries. I mean, especially, I mean, they do a pretty good job now. Like I know, like a lot of DJI's products with their enterprise drones, like the you mentioned the Mavic 2 Enterprise, also like the M200 and M300 have self-heating batteries. So
mm-hmm.
like here in New England, when we're flying in winter, like that's a pretty handy feature to have to keep the batteries in that operating temperature window. That's usually specified by the manufacturer, I should say. But also to your point, like if you're operating somewhere where it's very hot and you're dealing with really high ambient temperatures that are not allowing those batteries to cool, because they're also going to become very hot when you're draining those batteries, because
Mm-hmm.
you have four big motors all drawing amperage off sometimes usually a single battery. In DJI's case, they have the redundant setup and they have two batteries. Nonetheless, that can drive the temperature of the batteries up. So you do want to probably make sure like you're, have your car running or something, and like you're
Mm-hmm.
blowing the air conditioning over them or putting them somewhere in the shade. to keep the temperatures in a nominal or operating window that would not degrade their health, so to say. So that is
Yeah,
an important thing,
exactly.
a good call out, yeah, for safety.
And so, after we fly the inspection, a common question is, what do you do with all like the images? Because the drone is just taking like, hundreds or thousands of pictures. So, you're not looking at every single one like individually, like on the computer, like, oh, like I see something here, but like, where the heck was that on the site? Like, because you
Right.
can't really figure out its location to, unless you have geotagged. But
Not immediate, not immediately. I mean, right. Like sometimes you can be lucky and like a site that you're working on is on like Google Maps or Apple Maps or
mm-hmm,
something, and is has like recently been scanned in via satellite imagery. Yeah, you can take like the metadata and sometimes you can correlate that longitudinal data to what's on Google Maps, for example, and that can give you like a rough idea. But that's still not perfect. Like it doesn't necessarily always isolate where an anomaly is, because a lot of the times, like for newer, for brand new sites that aren't available to see in some of
satellite
those.
photos,
Yeah,
yeah.
yeah, exactly. You're going to have a lot harder time trying to correlate that information.
Mm-hmm.
And there are ways of getting around that.
You're not, again, we're not looking through them all at one time, but we actually use like these different software programs. So there's lots of them out there. There's Raptor Maps, Aerospec Technologies. I know Drone Deploy is working on one. I think DJI is working on one, and there's a couple of other ones that are from not from the U.S. but they're overseas. I know in Europe area that they're also developing their own platform. But basically, you kind of just upload all these images, and then they have these different AI software that actually can analyze them and find the different types of anomalies. So, and then basically you get this report generated, which goes over all the different photos that were taken, and sometimes like takes your as-built drawings and then overlays all the anomalies onto there as well, so you can easily locate all the problems throughout the site. And so with that, really, they're going to also be showing you exactly how much like kilowatt hours are being lost, every month or every year. They even factor in like your a local um, cost per kilowatt hour. I'm pretty sure like how much the energy is being sold for in the local area, and so they factor in how much money we have this string defect here. How much money per year if we don't fix this is it going to cost us?
Right. Yeah. Well, there's a couple things in that to touch on. So, like the first thing, so being like, so wow, because a lot came to mind there. So, yeah, so Raptor Maps is like one of a couple different companies that will aggregate data and be able to generate a report and put on a map where all your anomalies are and like what that is costing you in terms of degradation of performance or like financial earnings, which is like really cool to see and very helpful because that can kind of provide some immediate feedback. Um, yeah, kind of jumping around, but like I think DJI's software is Terra, something like that is
Yeah,
what
I
they're
think
pushing.
so.
Um, yeah, and that's going to be theirs, like right, and then so you also have like Pix4D is also able to generate orthomosaics and do create maps of your sites. So there's a lot of different like software avenues you can go to kind of create a picture of your site from an aerial scan,
Mm-hmm.
and that will kind of help you tag and make markings and notes of like what the anomalies are. So I find Pix4D is personally like pretty helpful when you're trying to review visible imagery and like performing like an audit of your site in terms of like what like if there's cracking or soiling, anything that you can kind of detect visibly with your naked eye that you get from the RGB imagery from that particular sensor. um, that's a software platform that you can kind of go through and see things, right? Because you also mentioned it's really inefficient and a poor use of your time that once you collect a set of data, sometimes on like the small end, you can have like a couple hundred images, right? Like,
Yeah, yeah.
like I think like some rooftop sites, you're still going to end up with like, 80 to 100. Like that's still a considerable amount to like sift through. If you've ever taken like too many like vacation photos, like you kind of know like the pain of like kind of going through like, oh no, I'm like my eyes are closed in this one, or like there's a lot of them aren't very good, and there's only a few select ones you want. But my point being is that when you're trying to go through all like 80 of those photos, it can take a lot of time just to find like one bad anomaly. That's like a little Excel defect or something. So we feed all of this imagery, especially when it's in the thousands of photos from a very large site, into something like Raptor Maps is a good example that aggregates all that data. And then, as you said, there's an AI or machine learning software that kind of goes through and like it gets better. Like the more images of like solar farms you feed into it, it gets better at detecting these various anomalies and can do a pretty good job of tagging and pulling out each one of those photos out of thousands that have those anomalies in them, whether it's something as small as like a cell anomaly, which is like those little squares in the solar modules, or like what we're really after are like the string outages that are really causing a deficiency in terms of like financial income from production of the site. So like that can be like a huge time saver, because like that will come back in a couple days versus like, I don't know, I don't really want to think about it, like however long it would take, like performing your own internal review and report. That is like something I've done on a couple one-off cases where we wanted to keep it where we wanted to keep the review internally and review it ourselves. And I can say it does take a lot more time. It also takes more people, because you need to have more eyes on it, because like humans make mistakes all the time, and so you kind of go through like all these drafts and revisions of a report as more people look at it and be like, hey, did you see that? And you're like, no. And so you kind of have to go back and include those in each revision, and that can definitely take a lot of time and energy, as opposed to these AI platforms that are coming out now that have very high success rate in terms of finding all and correctly identifying all these anomalies. It's just a big time saver.
Yeah, for sure. All right, so moving on to the next question we have. So how do drone inspections of these PV systems actually save money? We keep on hearing how they're cheaper than doing it the previous methods like IV curve tracing and the handheld thermal imagers, which honestly I can't believe like being out there like doing that one at a time, just like scanning every single one.
No,
I mean,
stuff at
I know they did it.
nightmares.
I know they did it for like a lot of people might still do it, but it's honestly I mean I personally wouldn't want that job, but so
Yeah, like it's right, like as you said, it's a lot of like physical labor, like going out there like under the hot sun, right? So like it has to be like the same conditions to get those good data results. So like you're there out, like especially like I feel like you mentioned earlier, like being out like at some of these sites that like are in like the Southwest, or like out on the West Coast, like very hot. Not really like any shade, like sure, probably like you're going under the panels for like a water break, like every half hour. But just like the amount of ground you have to cover, right? And again, like people make mistakes too. Like, did you skip a row? Like that'd be pretty terrible. Like, if like you missed something or skipped over something, because that's very likely, unless there's like a particular region or area you're trying to capture data from. So that can, lead to some false positives, or just the failure to collect the right imagery. So drones definitely help decrease error and also increase efficiency, because you can cover such a wide area in such a very short amount of time with like 100% confidence that you've captured everything and you haven't missed anything. Definitely is a big help.
Yeah, that's a big one. One of the sites that we just inspected, this was their first time actually implementing drones for their solar inspections. And I remember I was talking to one of the technicians, and he was saying, yeah, this site in particular, these panels are stringed up just by 6 modules in one string. So the IV curve tracing, they do it by string, so they'd only be looking at 6 modules at a time. But there was like 57,000 panels or something like around that area.
Wow.
So think of how many like individual data points they had to get. And
Yeah.
it would take them, sometimes he would say like it'd take us like a month, to do this with like a couple people out here. And it's just like really like that inspection, took around like a day and a half. So it's for the drone, that is.
Yeah.
So it's really just like reducing like these man hours, and all this like technician labor out there.
Yeah. So put that in perspective though. So like to do a day and a half, like that must be for with a drone. Like that's got to be a very large site then.
Hmm.
Like couple hundred
Yeah.
megawatts or
No, it was around like 30 megawatts.
30. Okay.
Yeah, but like it was like the drone was flying really low, like the most detailed inspection method. So it just takes,
Okay. Gotcha.
yeah, it just takes a lot
So
longer.
you were aggregating a very high level of detail.
Yeah,
And like,
correct.
gotcha. That's awesome. So yeah, typically that's also, or at least in what I've seen, that's a very comprehensive um, collection of data. So like you can see like you can see in the thermal imagery like each little rectangle. You can see each little cell with like a lot of high fidelity and
Hmm.
high resolution. Like typically, like what we do is like a standard inspection that takes place at like 200 feet, and you can still make out cell anomalies, but not with as great a detail as you would like doing like a low flight. Um,
Hmm.
and like that's kind of the thing too. Like with drones, you have a lot more flexibility and options. Like you can spend more time doing an inspection, but on the flip side, you'll get a higher level of detail and more comprehensive report. Uh, and then on the different side of the same coin, you can do a much higher altitude flight and get a much broader overview that takes like 5-10 minutes. That of course depending on like the site size. Like if you wanted to do 1 megawatt, you could probably do that inspection at 200 feet in about 10 minutes. And depending on what drone platform you have, like whether it's something like the M200 paired with the Zenmuse XT2 or the M300 and the H20 T that have those multiple sensor payloads, then you can collect both visible and infrared spectrum
Hmm.
imagery in one flight, and then you're done, which is great.
Hmm.
As opposed to doing two separate flights where you're either swapping out the payload or you're using two different drones, each with those different cameras equipped.
Yeah, and it's also like just like how fast like we can deploy the drones too. Because I was talking to someone else as well, and they were saying like they would do like Cessna aircraft the
Oh
thermal
yeah,
inspections.
that's wild.
And yeah, and but like what they would do is actually like group multiple sites in the same day, because so the plane can just like fly around and do the inspections like throughout the day. 'Cause it's just like more cost effective to do them all at one time.
Right.
But he was telling me, he was asking me, how soon, like, say like we wanted to do the inspection like right away, like how soon could the drone, get out there and be deployed? And I'm like, really just depends on the weather, and of course, the schedule if we had other inspections to do. But really, that's just the biggest factor. And he's like he's like he didn't even believe me. He's like, that's it, because like the Cessna, he was saying that it took over 2 months to schedule something. Uh,
Oh yeah, sure. I mean, it's
yeah.
probably like like right, like the amount of demand and like how much. I mean, like I guess I'm be curious, like how many uh, businesses are operating manned aircraft that can perform thermographic
Hmm.
uh, inspections, and like right, because if there's probably not that many, they're probably like booking like way out in advance. So it's probably difficult, right, to get something like more immediate as opposed to like, drones, which, there's a lot of them, and you can, probably find like a contractor or someone that provides that service to kind of get that more immediate collection of information. Uh, Definitely, probably, is something that's more likely.
Yeah.
Right, because like all we have to worry about is weather. Like we don't have to put like fuel in it. Like our pre-flight checks aren't nearly as long. I mean, like let's if you're probably doing a manned flight, like you're going to take your time, right, with each pre-flight inspection. Probably going to make sure you go over things like twice or maybe three times, just to make sure everything is like meeting all the safety criteria. Of course, we're doing the same thing, but it's probably a little bit more comprehensive. Uh,
Mm-hmm.
as we're like not having to calculate like what's the center of gravity for like a drone like all the time, or like if we have like any additional like luggage that we're putting in it or something. uh, that's like gonna keep our pre-flight checks a little bit shorter, right? So like weather's kind of like the one limiting factor that would be holding us back to do like a kind of a quick response
Mm-hmm.
if
Yeah.
needed.
Yeah. So moving on to our next question. So how long do these inspections really take? So this is also, really commonly asked. And so it really just depends on a couple of factors. Basically, what level of inspection you're doing. Like we were talking before, there's different uh, inspection inspections that you can do where the drone would be, say, flying at a higher altitude, and the data wouldn't be as significant. Where you really finding like say string level defects at that point. But if the drone was flying much lower, it's going to take a lot longer of an inspection, but you're going to be able to see, down to cell level of any defects that come up. And so that's also a really big factor. And typically, personally, like we see like around drones being able to do around 10 to 50 megawatts a day if you're really pushing it. And especially if you have at these larger sites, if you have multiple drone operators, then then yeah, you can really significantly reduce the amount of time it takes to do that inspection.
Yeah, right. I think efficiency is like the main bullet point with doing photovoltaic inspections via drone, is just the amount of time you need to allocate for each inspection is a lot less than if you're going out there on the field on foot with a handheld camera and doing the same data collection. Uh, so and it's scalable. So if you're doing a small site, uh, generally, one drone is going to be able to handle that one field in a appropriate amount of time. It does vary pretty widely. So like in my
Mm-hmm.
experience, doing like a standard inspection at 200 feet, like as I mentioned, if it's like about a megawatt, that's going to be like 10 to 15 minutes to perform that inspection. We also have the
Mm-hmm.
benefit of having the multi-spectrum cameras that collect both sets of data that we need. So we're pretty much done in one flight. Like we have our wide angle camera imagery that we use to put together an ortho mosaic. We have the thermal imagery and the close up zoom imagery of like all the panels that we then process to find out what anomalies exist at a site. Um, like the most I've done is like 6 or 7 megawatts in one site, and like that can take about like 20 minutes, 25
Mm-hmm.
minutes. Like I don't think I've done anything like that took over like half an hour. But with that said, really all we need is just bring additional batteries with us or have an ability to charge on site so that we're constantly cycling through
Yeah.
batteries so we can uh, keep ready and have like a good amount of stamina for the drone so we can keep running throughout the day. Um, because we can keep like offloading data off the memory card or have multiple memory cards. So, like really there isn't like a limiting factor. Like batteries is kind of like the only one that you need to have like
Mm-hmm.
some kind of plan system, like either like a generator or some means to charge. Whether that would be like being able to plug into an inverter in on a solar site or something that's outputting AC current, or you know a DC battery like a car battery or something that would provide
Yeah.
power to let you charge. Um, yeah, so like that would be like the one thing. Yeah.
Yeah, it's a good point because like so like the aircraft that we use like on the Matrice, we're looking at maybe like 25-minute flight time with like the cameras all attached because the more weight on the drone is gonna make it fly less longer.
Right.
So there's that, and then but then like charging them up again, you do have to usually wait. Not everyone does it, but like wait until they cool down a little bit before you put them back on the charger. But charging those big beefy batteries up is gonna take like 2 hours. Because like it's honestly not that not that slow to get to like say 90% of the battery. But
Right.
then like that last 10% takes like so much longer, and you really need to be at 100% like or like 4.25 or 4.2 volts, because you don't want to don't want to start flying at the battery like it's 90% or something,
Right.
because that can potentially cause some problems. So
Right. Well, yeah, exactly. I mean, as we talked about early on, like the batteries are really like the main, fail safe, like the point that you want to ensure about the drone that it's healthy and functioning normally, that it's not over or under temperature, that you're not stressing the battery, because the DJI, their philosophy is that if you have multiple batteries and one fails, then you still have a power source to power the drone, because the likelihood of an ESC or motor failure is like less than 1%
mm-hmm.
statistically, so they say. As opposed to like Unique's approach, which is like, okay, well, like just put more props on it and it'll be fine. If something breaks, then you'll still have like 5 or 7 motors depending on your setup as octocopter, hexacopter. That's one perspective. But yeah, well, so with the M200, you're saying it's about 2 hours to charge a TB55, the big extra chunky battery there.
Mm-hmm.
The M300 with the battery charging case, we can charge in just about an hour. The TB60s, and like as you mentioned, like does a pretty good job of like kind of really just cramming electricity into the battery until you get to like that last like 10th, that last 10%, where it's like really trying to cram it in there, but it just takes additional time because the battery's already at like mostly at capacity. It just has to drop the amperage down to really kind of trickle in and properly charge that battery up, because you want to ensure that all of your cells that make up that entire pack are at proper voltage level, because you don't want any of them being charged higher than the other.
And that's something. Yeah, that's something good to know, because for like what I was talking about, my stock charger that comes like with the drone from the manufacturer.
Yeah,
like you can get aftermarket ones made by other companies who actually can charge the battery like significantly faster.
I think there's like a Colorado. I'm trying to remember the brand name.
Colorado drone chargers.
Yeah. Oh, there you go.
Yeah.
Those are pretty spiffy. Those do a really great job for the M200 batteries, the TB50 and TB55.
Yeah, so you can charge like multiple at one time as well. So
yeah.
But yeah, so on to our next question we got here. So how accurate are these drone inspections of solar farms? So, we clarified, these inspections are done really quickly, but is that actually any data loss in that time? Like that's something that I'm sure a lot of people might be worried about. If it's done so fast, well, how do you know it's going to be, accurate enough? So we see like when paired with like using post-processing software, like we mentioned before, they are able to actually identify 100% of the faults with 99% accuracy, and actually let you know exactly what the issues that we're looking at here, and of course, this can change if we're talking about like say like false positives. So again, like we said before, like if you're flying when you really shouldn't be, if it was a little bit cloudy, or like even like simple stuff like if there was like bird droppings on the panel, and I know. Like, I think I put this in here, but I know one time when I was doing like a school like PV system, like a pretty small one, there was like basketballs like up on there, like between the modules.
Gotcha.
And and I'm like, what is that? And like I went back like after I did the inspection and I'm like, there was like basketballs like covering the module, and I'm like, oh my god.
Just got like all this like sports recreation equipment like up on top of the school roof, like from all the kids just like kicking soccer balls and footballs up there, just like, wait, what? It's like, it looks like a giant egg. Why? Like, yeah, that would probably throw me off too. Yeah, so working like out in solar fields, like typically, well, so like you talked about how effective and like just exactly like, you know, how accurate are these reports, and so you kind of answered the question there. It's like they're very accurate. Matter of fact, like what I was gonna say is like sometimes we find so many anomalies that we don't know what to call them because they're so like obviously you have like things that have to do with the electrical circuits, like string, cell level. Like we talked about soiling, which is what you'd see in the visible imagery. But sometimes, like if it's a newly constructed site, we have like tooling or just like things that are left over from construction. So like you know, like power drills, nuts and bolts, or like packaging for like the solar modules. So like all that sort of stuff can kind of be present out there. That's aggregated and collected in the reports. Like that's kind of good to have, because then we can kind of you know, be able to provide feedback to our construction teams or contractors and be like, hey, like, you know, you left like a lot of stuff out there. Like when they say like, oh yeah, it's done and everything's cleaned up, we're like, oh, okay, great. And then we do a drone flight and then we find out it's like, no, like none of that is true. Like, so like, it's kind of nice to be able to do those internal reviews and then be able to provide that, you know, sometimes whether it might be positive specific feedback or negative specific feedback, kind of helps. Yeah. So in terms of like how much information is collected and like what kind of anomalies we see. But generally, yes, like there are sometimes improperly or incorrectly reported anomalies, but that's usually easily rectified. And it's usually like the difference between, you know, whether something might be pollen or dirt or like, well, like bird droppings can get kind of misconstrued for like, you know, if we don't do this, but at some sites, like they do like module washing. So like they'll actually treat and spray and kind of power wash the modules to clear them of, you know, dust or dirt, pollen, like things from like that might be caused from like wind erosion. And sometimes like the solution, the cleaning solution that they use can leave like a film or kind of like a, you know, like kind of like soap scum kind of like on top of the panels, and like that can be misconstrued as other things. That's just like a specific example that I've seen. So I guess what I'm trying to say is sometimes it's like too good. And like and you can kind of end up with like more things that you didn't realize were, I guess, possible. Like that's not something I had thought of before as like something I might see.
And yeah, we did talk a lot about different drone models earlier, but probably like one of the biggest factors that can determine how accurate the inspections are is the resolution of the thermal camera. Since, you know, the thermal camera is like the bread and butter of everything that's going on here, and it's what's finding all these different problems. So they have like some drone models, you know, which are cheaper, and if you're looking to actually get one, there's, you know, I would really do some research and figure out, you know, which is best for your needs, because there's some cheaper ones out there that have just lower resolution thermal cameras, and they really wouldn't work for solar inspections. And like a lot of the post-processing softwares actually don't even accept them like straight up. They say, you know, we don't accept this drone or this thermal camera because the resolution is way too low. So we actually have an article, I'll put that in the show notes as well, that talks about some different drones and thermal cameras that we recommend for solar inspections if you're looking to get one. But yeah, just like the resolution is just a huge factor when you're making your decision.
Yeah, because typically with the thermal cameras, like, and the resolution is typically something like 640 by 512. A lot of people would be like, whoa, like, you know, like my cell phone from like 2008 had better resolution than that. That's like, you know, that's like, I don't know if that is a megapixel or less, but yeah, you might think like first thought is like, oh, that sounds like a really small photo. Like my cell phone shoots better than that. And although at first glance that might be true, the thermal camera, each individual pixel has a temperature value associated with it.
Mm-hmm.
So it's actually a very powerful tool. And I think the point you're getting at is that's kind of the standard right now. And I know with I think the Parrot Anafi, not to throw that under the bus, but I might have to look that up. But the Parrot Anafi, I think in the early Mavic Enterprise, the first generation, only had like half that resolution. I think it's like 320.
Something like that.
It's already like halving what you would say is a small image. And so yeah, so to your point, it's not something you would use for a large scale inspection. But like if you wanted to take like a quick look at
like a residential, maybe.
Yeah, exactly. Like a residential solar roofing, or if you just want to be able to see like like there's a problem area, like or if there's like you want to be able to see if like heat is leaking out of a window in a home or something. Like it's good for those applications, like small scale applications. But where you really need a lot of like the most fidelity and most resolution you can get, and you're going to be doing like a large scale inspection, you definitely want to have that higher end equipment. I mean, and each software platform has hardware recommendations. So like Raptor Maps, if you go like on their help documents page, they have a whole list of supported drones and camera units. I'm sure Drone Deploy and Pix4D are no different, and they probably have a wider array of accepted products because they're also doing not only thermographic data collection, but also like visible imagery collection as well. So there's a little bit wider berth there for accepted hardware.
And also one more quick note is make sure you get a radiometric camera. So
right,
they have models that basically radiometric means that it's actually getting the temperature measurements out of the pixels that Robin was just talking about, because each pixel has its own temperature measurement. And so a lot of what we do in the reports is factor in severity of issues by temperature. So say like there's hotspots that are at a significantly high temperature and ones that are a little bit on the lower end, then we kind of prioritize, okay, this is the one you need to look at first. But they have cameras out there that are the same exact models, but for like, I think like $100 cheaper, and they're just like not radiometric. So you can't actually figure out the temperature from after you take the photo.
Right.
So
which is
definitely watch out for those.
Yeah, absolutely. Yeah, that's a really good point, John. Yeah, you want to make sure that you get the right equipment and that you're able to, basically just know that you can see the temperature values in the photo and be able to measure specific, points that you're looking at. Because one thing I think we glossed over is the whole point of like why these are effective is because like we're looking at electrical circuits basically. And whenever you're looking at an electrical circuit, wherever you have high temperatures is generally where you have higher resistance in the circuit and where something isn't functioning properly. So that's why being able to see things that have a high temperature reading is critical, because that could be a potential point of failure, or at least something that's degrading and over time will be a point of failure. And you want to be able to analyze that early on and get that on your radar so that it can be serviced before something significant, a significant failure takes place and kind of causes a substantial loss of power generation, and then that results in a decline in financial earnings basically.
Yeah. So, all right. Next question we got here. So, do drone inspections require plant downtime? So, no. All right. Next question. No.
Yeah, right. All right, let's do that one again.
So, yeah, you don't have to, do plant downtime when you're doing the inspection, unlike some of the other methods, because the panels need to be operating for the thermal camera to actually see the differences in temperature. So, if they're all turned off, then you aren't going to find any anomalies, and they're all going to look exactly the same every single panel.
Right.
So, yeah, that's pretty much all to say for that. That was pretty much all. It's just they're going to be on, and you'll be able to actually get an extra revenue, I guess, during the small inspection window time. So,
well, no, so that's a really good point, though, or at least something important to talk about. Or I guess I'm kind of just curious, John, but like typically when you do inspections, like do you have to contact the solar company and like let them know like you're going to be doing the inspection and to make sure like everything is switched on? Because like let's say like a recloser trips, which is basically, for people listening, it's kind of like the on-off switch outside of a solar site. So it's kind of what connects the solar site to the grid. And depends, but like usually there's the ability to like turn that switch on and off remotely for safety purposes. So like if a fire department needs to come to the site and they need to ensure that everything's turned off, those switches can be flipped. But like sometimes they can get flipped by accident. So like basically turning off a site. And so when you're doing a solar inspection, you might be flying over, and if a site isn't generating power, you don't hear like the inverters like whizzing and buzzing.
Yeah.
So like you kind of be flying over and like you're like, wow, like this is pretty awesome. Like there's no anomalies. Like my job here is done. Like I won't have any work to do after this. Is there I guess like a checklist or a process like you go through to make sure like you contact someone like, hey, is site A generating power right now, or do you guys have some kind of known issue that I should be aware about before I start this inspection to ensure that everything is switched on?
Yeah, that's a good point. So yeah, we always verify with our point of contact that the site is going to be operating, and sometimes they actually come out with us because they just want to see the drone because it's a cool piece of technology.
Yeah, definitely.
So if there are any kind of issues, or maybe for example, if I see a lot of areas where there's like no issues at all, and I'm kind of wondering if maybe this isn't turned on, then we'll just like make sure that it's verified that it is operating at that time. So
okay, gotcha.
Yeah.
At Nexamp we have what's called the Nexamp Energy Center, and it's kind of like this. If anyone ever gets to see it, it's kind of like this. Like if you've ever been to the Kennedy Space Center, and like there's this big control room, it's kind of like what it is. It's a little bit smaller than that. It's kind of, I think it sounds like ginormous, but it's basically a smaller version of that, and we can see, rather they can see all of our sites and like which ones are producing or which ones are having issues, because a lot of telemetry, we get a lot of telemetry from sites remotely, and they can read that in real time. And that's why I brought up that question, because that's something that's happened to me in the past where sites have gotten switched off remotely because they're doing some kind of check. And it's just like a kind of a clerical issue, or clerical error. Like someone forgot to check the service and maintenance calendar. And it was like, oh, Robin's out in the field today. Like, don't switch off the site. Like sometimes, people forget to look at that. It's only happened to me like once, but I just thought it was funny. I was like, huh, like last year this site was like, had some issues here and there, but it seems like they fixed all of it. And so it's just something I've always been aware of to kind of check ahead of time. It's like, hey, like you said, like have a point of contact, make sure there's somebody you can touch base with to ensure that the data you're about to collect or the flight you're about to perform isn't, wasted or in vain. You have to do like another one because that first flight, you actually didn't collect anything of value.
Yeah. So, yeah. All right. Next one coming up. So, can I use this drone data for warranty claims? So, this is also a really common one. So, oftentimes, say like during commissioning inspections, like when the plant was finished building and it's going to be really turned on for the first time. So, those inspections are really crucial to do because you're really verifying that everything was installed correctly. Like you were saying earlier, like there was a lot of like leftover equipment and everything. Yeah. So it's really crucial to do those inspections. And, usually I see that most of the sites are inspected like once or twice a year is common. We've often done commissioning inspections and then gone back every 3 or 6 months after the first inspection. So they can really keep tabs on it. Like right when it's first turned on and see if there's any like warrantable issues that are going on throughout anywhere on the site. And so you also have to factor in with these inspections. Usually they're going to be doing like the most comprehensive level one, which is going to find like every defect down to that cell level. And that's really also it's in compliance with those IEC standards for thermography solar inspections, which is often required. That level of detail is often required when you are submitting those warranty claims.
Right. Yeah. So like, there's no doubt that whatever the issue is a fault of the manufacturer or part of the assembly process, what have you, and not due to some other error. Typically it's just like the more information you have, the better, right? Where if you're able to provide more information and provide more context to why something degraded or is broken, like that definitely helps with your warranty claim process, being able to have that evidence showing, like, oh, hey, it's just been, we did the installation process correctly, and we haven't like switched anything on yet. It also just kind of, furthermore, we're starting to see with drones, it's really beneficial to do that initial inspection when a site is complete with a drone, because it provides us with a really good baseline and benchmark as to whatever issues we're having with the site. And it can be a variety of things, whether generally we're pretty good about shading, like where shading might come from. Like we have from an early on in the process during engineering and planning, like we're aware of like what tree lines might cause shading, but trees grow and that changes like it changes where the shading is casted, especially like in the winter time, that with that lower sun tends to elongate shadows, and sometimes that's not taken into account. And so like it's good to just see like establish like where that shading can be casted at certain times of the year. Also, like you said, because these sites haven't been turned on for a while, we just have like all of this equipment basically baking in the sun, for a year, and we don't really know what's happened to it in that time until we switch everything on. And then we fly a drone over, and then we're able to kind of pinpoint like, oh, okay, like these modules have reversed polarity, like, which is, for modules is kind of a big deal because, that's before it's been kind of inverted into an AC circuit. So like all the modules are in a DC circuit. So it's really kind of an easy mistake to make, to kind of just swap two wires around that aren't correctly installed. And now you have, a circuit that's trying to flow the wrong way, or is flowing the wrong way. And that becomes pretty evident when something's turned on. So like that's something easy to go out and investigate, because they can go on and be like, oh, okay, like, whoop, and then, swap around and fix that pretty easily. And then we can also get like a pretty good benchmark for, string, if there's any string anomalies present, and be able to establish like, where the production is at.
Yeah. So moving on to our last question that we have for this episode. So should you have an in-house or an outsourced program? So this thing is, widely controversial, talked about, I would say, in the industry for drones. So really what I recommend is really, it just depends on your company. So there isn't like really a straightforward answer. So it just depends how many sites you have, like whether you're a national company or whether you're just like super local, and how, how big your sites are, how often, you do the inspection. Maybe like if you only have a couple of sites and you're only going to, be doing the inspection, or maybe say doing, let's just say 5 inspections a year, is it really cost effective to get one of these really expensive drone models? Like the Matrice we're talking about, the Matrice drone, which is like the kind of the standard level, after you get all the cameras, the batteries, everything, like it can approach like around $30,000.
Oh yeah, I can testify to that. Yes.
So
yes, it does.
So you have to kind of put that into consideration, and then you also, which we haven't touched on yet, is the pilots who fly these things. They have to be licensed, and oftentimes, since we're dealing with thermography, they might also have like a thermography certification, so they understand like thermodynamics and how all that stuff works. So uh, that's definitely just a big factor, and there's just a lot more to operating these types of drones that then really meets the eye. Especially, I'm sure you've been, Robin, like really familiar with like sites that are like within airport areas, like
Oh
having to
yeah,
get clearance and everything.
yeah.
Yeah,
New England.
wasn't
Yep.
that that one site that you just got clearance out for like the rooftop system?
Oh, dry dock. Yeah, so we have a site that's kind of one of our older sites, one of, I guess, our original sites that have some older panels on it that we like to just be able to get a baseline of every year. And it's right on the uh, same approach as the southern runway at Boston Logan International. And it's right on a building on Dry Dock Avenue in the Seaport District of the Boston, metropolitan area. And it's a very like heavily patrolled area. Like you have a lot of state police, you have like a lot of maritime authorities, like Coast Guard, are like checking that area just because it's a very highly used, um, access point to Boston. There's a lot of shipping that comes in there, and it's also a very busy airspace as well, with like a lot of commercial aviation coming out of Logan. There's a seaplane, airport terminal,
Mm-hmm.
and it's just a lot of low flying helicopter flights, like whether that might be something like MedLife, where it's like trying to provide life saving services to people who need it. And that's like a whole other subject in itself. But anyway, yeah. It's important to know how to ask for and go through the right steps to getting a airspace waiver, whether that's mostly through the FAA drone zone portal page that they have set up to process those applications and to start that application process. It's important to understand what to ask for, and how to go about that. Like, what is the minimum safe altitude for your flight, right? Because although 100 feet might be easy to get permission for in a particular area, that might not be safe for your flight, because 100 feet from above ground level doesn't necessarily permit you, doesn't grant you like 100 feet above the tallest building. It gives you 100 feet above ground level. It doesn't give you anything more than that. So you're going to have a lot of vertical obstructions that are going to hinder the safety of your flight, or at least possibly going to limit where you're able to fly, because Boston, if anyone's ever been, has a lot of tall buildings, definitely more than 100 feet tall. And the particular building we wanted to fly was at 100 feet, so we actually needed a 200-foot waiver to get us that extra margin for safety from our perspective. And then we needed to be able to coordinate with that. We needed to be able to say, like, this is a small bubble that we're going to be flying in that's only going to be for this portion of the roof, in the area that we're going to stay inside of, to ensure that we don't wander off and fly into the rest of this busy airspace around us. It's also handy to have like an air transceiver,
Oh yeah.
which allows you to monitor air traffic, and just provide more information for your situational awareness. We also did that flight with a visual observer to kind of just help provide more information to the pilot, so that you're able to still stay focused on flying the drone, but also you're having that other person who's alleviating a little bit of that mental processing for you, to be able to, scan the surrounding environment and kind of help process that information and only call out what is important to you, or you would need to information that would be important to act on, versus like, just kind of more outside static that isn't as important. Things like that. I know that, so I kind of drifted off. I know that's more about like airspace authorization and safety. But like, what was the question? How did that start off?
Yeah, really just depending on whether you want to do the in-house or outsource program.
Right.
So
yeah, like you said, I don't think there's a wrong answer. I think it's kind of both can be pretty important. I've seen, from one perspective, I've seen companies, training their engineers and in-house employees to also be drone pilots, and kind of help push them and help them through that Part 107 certification process, because it's more beneficial to them that they be able to do like surveys and be able to collect information via drone flights from their in-house engineers, if they're part of like a surveying service or engineering firm. Nexamp, we are very unique in the sense that we do, everything like vertically stacked, everything in-house, like from building development, planning, engineering, the procurement of things, and then the actual construction. We try to do as much of that as in-house as possible. So that also includes like internally, we do all of like the asset management internally as well. So we have our own, service teams that will go out to sites and, swap out modules if need be, or like fix inverters. And, thus we also do our own in-house drone flights as well. And even though we're based in New England, we do have sites in the mid-Atlantic, down in Georgia. We also have a site in California. We're also expanding into New York as well as Illinois, the Midwest. And I'll be honest, that's outside of what we're capable of like servicing, in-house. Like, I'm based out of Central Massachusetts, so I can do everything in Mass. I can, get up to, a little bit in New Hampshire, Vermont, Maine, a little bit. And then, we can also get out to New York, but like kind of once we start to get past like the Hudson River, like, we're looking in excess of like a 3-hour drive, and that's a lot to ask somebody before, you start to look at the cost of, hotel lodging, and, having to, be able to make sure someone is set up for success with like, lodging, food, and those other logistical things that would help them perform their job to their highest level. So that's where we start to lean on, contractors such as yourself that are in different areas of the U.S. that we can ask to perform that work for us, because it makes more sense to have local people do the work local to that region, rather than, putting, as I put, we were talking early on, like, putting a tiny plane on a bigger plane and then, shipping that across the country, and then still having to pay for like lodging and all that stuff on top of it, kind of really inflates the cost of doing that inspection versus finding someone locally. And then, maybe all then we're worried about then is how like the mobilization fees, like how much is it going to cost to, make sure that that person has enough money for gas and, to compensate for the mileage accrued on their vehicle, to, hopefully like they're much closer to the site. So it's not going to take them, 3 hours to get out to a site. That's not always true. Like New York's a big state, so it does take time to get around. But the point being is that it's likely going to be a shorter transportation time for a local pilot than it is for someone like me who has to, plan out a road trip basically, and lug, $30,000 worth of equipment like halfway across the country. Like it starts to not make a lot of sense. Like you're like, okay,
Yeah.
like this doesn't add up.
And that's a good point too. Is so a lot of like these drones too, like these, especially like I'm talking from personal experience because we have like the Matrice DJI Matrice 210 V2, and that one only came out I think 2019, I believe. Don't quote me on that, but already today we're seeing they already discontinued this model at the company DJI. Already discontinued the model that we bought.
Yeah.
And now recently I've been looking to actually buy more batteries, and there's like this whole shortage of batteries, and they're out back ordered, like you can't get them. And
I feel your pain.
I know. I'm talking to like
yeah. We have an Inspire 1 version 2, which was discontinued. Yeah, some time ago. I'm not exactly sure, but same problem. Like like DJI being a Chinese company. This is kind of like one of the downsides is that like they do a good job of maintaining their current supported drones. Like they'll they'll produce parts for them, but like once they discontinue something, they don't have the same laws like here in the United States. Like where like if I needed to service my old Buick or something, like I can go into a parts store and I can get the parts for that to service it and get it back on the road and running. Unfortunately, DJI doesn't work the same way, where if they decide to discontinue something, then that's it. That's kind of the end of that particular product's lifespan. And you can go out and get as many batteries as you can get to kind of elongate the lifespan. Because that's kind of like the limiting factor, right? Because that's like the one part on our drones that has like a I don't want to say it's a moving part, but it's like kind of going through a lot of, I guess, stress, right? Because like we charge it up, and then we pull a lot of voltage out of it during a flight, and so like over time, the lifespan of that capacity of the battery degrades, and so at a certain point, like there's going to be a diminishing return in terms of like flight time, where it's not going to be acceptable or not a safe idea to put an old highly used battery in a drone. Like you're gonna have to retire that platform, and so that's kind of like, but what we're trying to overcome is like future planning. You can't necessarily future proof. Like eventually, technology becomes obsolete, and you have to move on, or you move on to the next best thing. But yeah, we're experiencing that with our Inspire drone because you can't find OEM batteries anymore.
Yeah.
And our policy, the way we have it written, is we don't want to rely on third-party batteries or parts because then you start to introduce unknown factors, and you can't really verify the
safety and everything.
Yeah, exactly. So that's not a risk we're willing to take. So that's kind of the direction we decided to move in. Was like, okay, let's jump on the latest flagship, and then currently DJI's released the version 3 firmware update for the M300, but it's currently supported, but we're going to face that problem eventually when whatever the M400 comes out, and then we're all going to be like, and then we're going to have that same problem where we're going to have to accumulate and keep this stock of TB60 batteries, which is what the current model is that works in that newer drone, to keep that running for a while, because eventually that'll be the problem we're faced with.
So yeah, this is like the thing with drones, because like I said, if you're only doing a couple of sites like say per year for inspections, then getting this really expensive drone model and then in 2 years having it become kind of obsolete, and then having like, if you have a crash, like the parts can become hard to find and everything.
Yeah.
That's like a huge expense that a lot of these smaller companies can't afford, like to change everything like in 2 years and get like the newest model. And because like the drone stuff is not like buying like a brand new like truck or something that which you could have for like 10 years
right.
or more. and it would be, it's still supported for a long time. So that's just a huge factor. And then there's just like, I'm sure there's just like so much that goes into flying these things. A lot of, we talked about a lot of it already, but and it's also important is that whoever you put in charge of flying them has to stay like current with like new drone laws, which always change too.
Yeah, right. We're
So
getting remote ID is going to be coming out, and that'll really be a shift in the landscape. I mean, like we already have a pretty good idea of what to expect that's been laid out before us from the FAA. But that'll be, like you said, like keeping up to date. I mean, you want to make sure that whichever pilot you're using not only has their Part 107, but also has like the most current certificate of the proof that they've taken the knowledge exam and passed it, to show like that they're up to date on the most latest safety information put out there by the FAA. Mm-hmm. That's really important because you can have somebody with a license that dates back to 2016 or something. That's not exactly, that is part of it. That definitely shows that they have gone through and at least done the initial knowledge exam test, but you need to be able to show that you've also have the every 2 years you have that the recurrent, thank you, that's it. Yeah, exactly.
So yeah, I think that pretty much covers it for all of our questions we have for the episode. And if you want some more information, like trying to figure out whether you should have the in-house or outsource, we also have another article which I'll link below, which is kind of like our ROI, like return on investment guide for these drone inspections, like in asking you kind of listing a lot of questions that you need to ask yourself and your company needs to discuss whether it's going to be a good idea to outsource or to have it in-house. So, but that pretty much covers it for this podcast episode. Robin, I appreciate you coming on and talking.
Yeah, definitely. John, thanks for having me. I mean, I really appreciate it. It's always great to talk with someone like-minded about drones that's also passionate about it. It's also, an entrepreneur and, making a living doing something that's pretty cool.
Yeah. Appreciate it. So, but anyways, if you want us to come out and inspect one of your sites, you can always contact us on our website, and I'll also put our LinkedIn profiles because both of us are pretty active on LinkedIn. If you ever wanted to reach out to us, ask us any questions or anything you might have, then always feel free. So that's pretty much it for this podcast episode. Please like and subscribe, or write a review, whatever platform you're on, and we'll catch you on the next one. Thanks for watching.